Okay, good morning, guys. Today, inshallah, we're gonna just make a kind of practice of chapter 22, section 2. We're talking about the different hydrocarbons, so we're gonna know how to write the structural formula of alkane, alkene, and alkyne, and also how we use the AOPAC system to name the different hydrocarbons. So let's start here, guys, by the first question. So he asks you to write the structural formula for each of the following compounds. First one is propan, so let's see how we can write it. So propan, and that's mean reflex for alkane, which suffix for alkane, which means that we have a single bond. Prop, that means three carbons. So we have three carbons that they have a single bond between them. So the structure formula will be like this. Okay. Okay. So of course this into Dutch means they are bonded to hydrogen. Okay. So you can write the hydrogen or you cannot. Okay, as you want. Okay, it means there is a hydrogen already. So like this here, that is propan. So that's number one. Then he asks you second one here that so that's number one. Number two, he asks you write the chemical as the structure formula for 2-methyl propan. So we have the propan, okay, and then we have in carbon number two we have a branch or we have a methyl group CH3. So we're gonna do the same, but we just replace one hydrogen by CH3. So it's gonna be like that. One, two, three carbons, okay. So they also as and so they have single bond between carbons, and here we're going to just add CH3 instead of one hydrogen. So one hydrogen is replaced by CH3, so it's 2-methyl propan. Then he asks you to write the chemical formula of butan. That means four carbon, and as it ends by an, so it means we have also single bond. Okay, so that's number two. Let's make number three. Butan, four carbons. So one, two, three, four carbons. They are bonded to each other by a single covalent bond. Okay, that's why it's ended by the suffix "and." So that is butan. Then here 2-methyl butan. So the same here 2-methyl butan. So we're just gonna replace that's number three. So number four, they're gonna be the same. Okay, four carbons. One, two, three, four. Okay, and in carbon number two, we're just gonna replace it. Okay, by one methyl instead of the hydrogen. So we're just gonna put here methyl group. Okay, so that will be carbon number two. You could put it here, and in that case, we're gonna count from this side because we count from the side which is near to the branch. Okay, so like this, we know how to write the structure formula of this compound. Then let's pass to the next question. He asks you, okay, to use the name to or use the effect system to name the following. So here, this one, how many carbon do we have? We have two, so we use the number F. Okay, if that means two. So if two, and here it has double bond, so we are gonna use the suffix "-ene", so ethene. So and there is no branches and just two, so we just its name will be ethene. Okay, so let's right here. So if that means two, and the by ene, so it will be ethene. Okay, so this one here we have okay two. We have one, two, three, four. So we have four carbons. Okay, so as four carbon we have the okay number put. Okay, and as it has double bond, so we add the suffix "-ene", so butene. And then we need to determine the position of the double bond. So we have double bond between carbon number one and carbon number three. So we have one, okay, three, okay, butene, okay, so or one, three, okay, that's bu. And in here we're gonna just change this one, okay, because we have 2 bonds, so we make it a d. Okay, so why adene? Okay, because we have a diene. Okay, so a diene, that means we have two, okay, bonds. So di because the R2, and the in, that's to represent the R2, okay, double covalent bond. Then here let's pass to the next one. Okay, number seven. So number seven here we have one, two, three, four, five. The R5 carbon that belongs to chain. Okay, yes, that belongs to chain because if we just count like this, one, two, three, four. So we have that belongs to chain R5. So at the R5, so we're gonna use the number, okay, pent. So it's pent, and the kind of the bond between all the carbon is single bond. So we are gonna use the suffix "-an" because it's alkane. So pentan, that is pentan. So then we have a branch. Yes, we have here a methyl group CH3. It's located on carbon number three. So we're gonna say 3-methyl pentan. Okay, so that's how we name this one. Then let's pass to the next one. number 8. Okay, so in number 8 here we have 3 carbons and we have double bond. So and we here have bromine. Okay, also that's a kind of branch. So we need to name this. How we are gonna name it? So 3 carbon, that means prop. Okay, and as it has one, so we are just get in, so propene, because we have one double covalent bond. It's found in carbon number 1, so 1 propene. And here we have a branch. What is this branch? That is bromine group, so it's located on carbon number 2. So 2 bromine, okay, 1, so 2 bromine, okay, bromide, okay, 1 propene. That is, or that's how it's look. We name this one. Then let's pass to the next question number 9. So in that case here we have 1, 2, 3, 4. That is, okay, as we can see here, it's a cyclohexane. Okay, so that's cyclohexane. So the basic that's ring is cyclohexane, and here in that case we have a branch in carbon number 1 and carbon number, okay, 3. So in that case we are gonna name it, okay, or that's why, or in that situation we're gonna say 1 and 3. Okay, so 1, 3 dimethyl cyclohexane. Okay, so in that case here we just name it 1, 3 dimethyl, okay, cyclohexane. Okay, so in that case here, we're just let's pass to number 10. So number 10, you're gonna find that they are 5. Okay, so that's mean they are pentane, and as it's found in a cycle, okay, or a ring, so we are gonna find cyclopentane. And here we have the ethyl group. They are attached in carbon number, okay, 1, 2, 3, 4. Okay, so we can say it's 4. Okay, so that's here 4 ethyl cyclopentane. Okay, so like this here, guys. Okay, guys, then we are gonna pass to question number 11. So here, how we could name this here. Also, we have a ring that made of 6 carbons, so it will be hexane, and as it's a ring, so we're gonna call it cyclohexane. And here we have this methyl group, so we're gonna say methyl cyclohexane. Okay, then here let's pass to question number 12. So here 1, 2, 3, 4. So we have just as long as the chain is 4 carbons, so they are 4 carbons, so it's but, and as they have one single bond between them, so we're gonna use the suffix and, so it's butane. And here we have 2 branching group. Okay, so they are in carbon number 2 and 3. They are methyl group, so we're gonna say 2, 3 dimethyl butane. And then here let's find this one. So here we have 2 double bond, okay, between 3 carbons. So we are going to use the word prop. So the R2 double covalent bond. So we're going to add the suffix again, okay. So that's to reprint, and they are found in carbon number 1 and 2. So they are 1, 2, okay, propadiene. So here let's pass to question 14. Okay, so question 14 here, let's find the longest carbon chain. 1, 2, 3, 4, 5, 6. So they are made up of 6. So 6, that means hex. And as we have a triple bond, so we are gonna say hexene, okay, or hexine. So we're just here, there are 6 carbons. So need to locate the position of this one. So it's 1, 2, 3. It's in the 3, okay, or the third carbon. So it's 3 hexine. So then pass to the next question 15. So here 3 carbons, so they are gonna be prop, and as we have just one double bond, so we're gonna use the ene, so propane, and we need to locate this the location. So one, because we count from the nearest side, so we can count here. So it's carbon number one. So it's one propene. Okay. So then here pass to the this one, okay, or the number 16. So you can, in this one 15, you can say propane, even no one propane, because whatever events here, it's gonna be also called one propane. So you can even don't mention, if you just say propane, also, only it's gonna be okay. So let's find here we have three carbons, okay, and that is the triple bond, so it will be the same, but change it, the word propene, okay, so it will be propine, okay, because we have a triple bond, and also it's not matter to mention this, because if the bond will be here, so it also will be one, because we just count from the nearest side to the bond. So here let's pass to question number 17. So this one, we have the R2 chlorine, and this two chlorine are found in two different sites. So we need to mention here the geometric isomer, the R cis or trans. So of course you can say the R trans. So we have two chlorine. So we are saying that the R, okay, here trans or di, okay, trans chlorine or trans dichlorine, trans dichlorine, chloride, okay. And here the R2 carbons, okay, so the R ethene, because we have double bond, okay. So like this, okay, we represent that, or that's here represent the idea, okay, or that's here. So trans is just to say that they are found in two positions, because if the chlorine are in the same one or in the same side, we're gonna call them cis, okay. So then here pass to the last one, this one, two carbons, so the R eth, and we have here, so triple bond, so we're gonna say the R ethine, okay, or as you can see, and that's it. So I hope it's clarifying the idea how we name, okay, different hydrocarbons and how we write the structure formula. Please study this part very well, and if you have any question, you are welcome anytime. Thank you guys, and goodbye.